Hello and welcome. A lot of the questions that we ask in social science have to do with things like public opinion or trying to predict the outcomes of an event like an election. And when we have a research question like this, a common methodology for answering that question is to take a survey and ask people about how they think about something or how they're likely to vote or some other outcome that we're interested in. In this lecture, we're going to be talking about how we take the sample of people who we're going to administer a survey to. But before we get there, let's talk briefly about why we sample in the first place. This is a little bit of a review from previous lectures, but just as a refresher, in our studies, when we're doing a research project, we're interested in some population parameter, some feature of the population that we're studying. But we are usually not in the position where we can collect data for the entire population that we're interested in. And so we take a sample from the population in lieu of taking a study that looks at the entire population. And then based on that sample, we are going to compute a statistic that's going to be our estimate for the population parameter that we're interested in. Up to this point in the class, we've been making the assumption that the samples that we take from a population are simple random samples. In this lecture, we're going to be talking about other ways that we might take a sample. As a reminder, a simple random sample is based on this method where any possible sample of a particular size has the same chance of being selected, or equivalently, that any member of the population has an equal probability of being selected to be in the sample. We're going to be talking about non-random samples in the next part of the lecture, and after that we're going to talk about a couple of different ways that we can take random samples other than simple random samples. A random sample is also known as a probability sample. And if we take a sample with methods that are not random sampling methods, those samples are going to be called non-probability samples. So let's talk about a couple examples of these. One example is a convenience sample. So this is the sort of sample that we take based on the people that are most available to us, most convenient for us to include in the sample. So for example, if a researcher is working at a university, probably the easiest subjects to take part in a survey or an experiment are going to be the college students who are also at the university. So a sample of college students in that situation would be a convenient sample. Another type of non-probability sample is a volunteer sample. Examples of this include a poll on the internet, where the people who take the poll are just the people who run across it in the course of their web browsing or are sent it via email or something, and these are people who just opt in to taking the poll when they run across it. And another example of a non-probability sample, a non-random sample, is a purposive sample, where the researcher doesn't make an effort to draw a random sample. The researcher seeks out a particular group of people with particular characteristics and just asks them to answer the survey questions. So for example, an expert survey is a purposive sample where the researcher is trying to understand the views of experts, people with a particular background in a subject matter that the researcher is interested in. So remember that when our samples are not random, we can't make inferences from the sample to the general population. We talked about this in a very early lecture in this class. So non-random samples, non-probability samples, are going to suffer from sampling bias. They're not going to be representations of the population as a whole. There's going to have some bias, some difference from the general population. Depending on your research design, it's not necessarily a problem that the sample that you're working with isn't random. Lots of experiments are based on non-random samples of college students who sign up to do an experiment or to take a survey or something like that. So it's not necessarily an issue for a researcher that the sample that they're working with isn't random, but it does become a problem if the researcher doesn't understand that the sample that they're working with is a non-probability sample. Let's look at an example to illuminate this a little bit more. In 1936, in the presidential race, Alf Landon was the Republican nominee, and he was running against the incumbent FDR. Unsurprisingly, lots of people were interested in finding out what the outcome of this election was likely to be. The Literary Digest was a popular weekly magazine, and the Digest did this poll of about 10 million Americans about the presidential election to try to figure out how people were going to vote. They sent out this poll to 10 million people and they received about 2.4 million responses back. And the results of this poll showed that Alf Landon was likely to be the winner of the presidential race by an overwhelming majority. Their poll indicated that if people voted the way they said they were going to vote, FDR would get only 43% of the votes. Now, in reality, in 1936, FDR won an overwhelming majority of the votes. He got about 61% of the popular vote, and Alf Landon only got around 36%. So the Literary Digest poll, despite being based on this massive sample, was really wrong. And the magazine was so discredited after this poll that might have contributed to the magazine shutting down shortly thereafter. So what happened? How did the Literary Digest poll get it so wrong? Well, the answer is that the magazine's survey was sent out to the magazine's readers, to people who were registered owners of cars, and people who were registered users of telephones. So, in 1936, we're still dealing with the Great Depression, and people who are subscribing to the Literary Digest and who own cars or own phones are more likely to have incomes that are well above the national average at this time. So the Literary Digest was polling people who were more likely to be wealthy and more likely to support Republicans than a really typical voter at this particular time. So the answer is that the sample wasn't representative of the American population at the time. So the national election results weren't reflected by this sample of a particular type of American voter. Throughout this class, we've talked about the idea that taking a large sample is likely to improve the quality of our research and how confident we can be in our results. The lesson from the Literary Digest example is that having a large sample isn't the only thing that you need to have good results. If your sample is biased, even taking a really large sample isn't going to do the trick. So even though the Literary Digest took this huge poll of about 2.4 million people, the sample was biased. They weren't taking a representative sample of the US population. They were oversampling people who were more wealthy and more likely to vote for the Republican candidate. And so even though they had this survey based on all of this data, the survey results didn't give them an accurate prediction. If the Literary Digest had just been trying to understand how people in a particular demographic were likely to vote in the 1936 election, this research design might have been just fine for them. But where the Digest went wrong was in trying to generalize to the entire voting population in the United States in order to predict the results of the presidential election. So there was a mismatch between the research design and the question that the Digest was trying to answer. If they'd been trying to answer a different question, this research design might have been okay. If they wanted to stick with this question of trying to predict the election results, then they would have needed a different research design where they took a random sample from the population. So with that in mind, let's consider this example about survey research. So let's say that a school district is considering if it's going to continue to allow high school students to park at the school after 2 recent accidents where students were severely injured. As they try to decide whether they're going to adopt this policy, they send out a survey to parents of the students at this high school, asking whether or not the parents would object to this policy change. So they send out 6,000 surveys and 20% of them, 1,200, are returned. In the 1,200 surveys, 960 agreed with the policy change, so agreed that it would be a good idea to not allow students to park at the school anymore, and 240 of the returned surveys disagreed. So, of these following statements, which of these are true, keeping in mind that multiple of them might be true? Is it true that some of the mailings may never have reached the parents? Does the school district have strong support from parents to move forward with this policy? Is it possible that the majority of parents of high school students disagree with the policy change? Are the survey results unlikely to be biased because all parents were mailed a survey? Take a moment, pause the video, and see what you think. Okay, So, for this first option, it is true that some of the mailings may never have reached the parents. Some of them might have gotten lost in the mail, some of the parents might have thrown them away with junk mail, any number of things. There's no guarantee that all of the parents of these high school students actually saw this survey. It's not true that we can conclude that the school district has strong support from parents to move ahead with this policy. So, because only 20% of the surveys were returned, it's possible that the parents who returned the survey were the ones who had a really strong opinion about this particular policy change, and that the 80% of the surveys that were unreturned might actually contain a lot of parents who don't want this policy to go into effect. So we can't conclude on the basis of these survey results whether the school district actually has support to go ahead with this policy. It's true that the majority of parents of high school students might disagree with the policy change, like we just talked about. Because 80% of the surveys are unreturned, it's possible that the majority of the parents don't want this policy to go into effect. And it's not true that the survey results are unlikely to be biased just because all parents were mailed the survey. The parents who sent back the survey are the ones that we want to think about. Are those parents more likely to have particular characteristics that make them different from the parents who didn't respond? For example, are the parents who mailed the survey back ones who maybe were more likely to know the injured students and have a really strong opinion that the high school kids shouldn't be able to drive and park at school anymore? And that the parents who didn't return the survey might be those who have a less emotional response or a less personal experience or something, some characteristic that just made them both less likely to send the survey back and less likely to approve of this policy change. So just because all of the parents were sent a survey doesn't mean that the survey isn't going to be biased. So that has been our discussion about taking non-probability samples or non-random samples and some of the consequences of doing that. Now we're going to shift our focus back to looking at random samples or probability samples. So there are a couple of ways that we can take random samples. We've already covered how we go about taking a simple random sample. We're going to introduce the concepts of stratified and cluster sampling as well. Let's briefly review what a simple random sample looks like. So in the entire population that we're interested in, we're just going to randomly select individual cases or subjects or whatever from this population. And there's not any implied connection between these selected points. We are assuming them to be independent from one another and not to necessarily share any characteristic in common except for that they're a member of the population that we're studying. Another random sampling technique is to take a stratified random sample. So when we take a simple random sample, there's going to be variation in the types of cases that we pull into our sample. If I'm concerned about making sure that in my sample I have a good representation of different subgroups of respondents, then I might want to do a stratified random sample. So let's say that I was surveying the US adult population, and I want to make sure that I don't get myself into a situation where I have a sample that's like 90% men and 10% women, or 90% women and 10% men. I want to make sure that I have an even balance of men and women in my sample for the benefit of my research design. So in this case, what I might do is take a stratified sample. I would take my population and I would divide it into these subpopulations, in this case, a male population and a female population. And I would take a random sample from each of those populations of the same size. So I would take from the male subpopulation, a sample of 100 respondents, from the female subpopulation, a sample of 100 respondents. And that way I would make sure that in my sample that I end up analyzing, that I have an equal number of male and female respondents. So that is what a stratified sampling strategy does. I can stratify on any number of indicators. For example, I might want to make sure that I have people of various socioeconomic statuses represented in my sample. So I don't want to end up with a sample where I've only sampled people in the middle class. I want to make sure that I sample people who are relatively poorer, relatively richer, and things like that. Or I might want to stratify on the basis of education level. I want to make sure that I have people in my sample who have just a high school education or lower than a high school education, all the way up to people who have graduate degrees. So those are a couple of different ways that I might do a stratified sample. First, I stratify my population into these particular categories that I'm interested in, and then I take a random sample from each of those strata, each of those categories. Another random sampling strategy is to take a cluster sample. So in this sampling strategy, what I do is I divide my population into particular clusters with heterogeneous populations within each cluster. So unlike in the stratified random sampling case, I'm not grouping together my population observations based on a particular characteristic. I'm just dividing them into particular clusters. And then I take a random sample of those clusters and take a simple random sample from within each of those clusters. So for example, let's say that I was trying to answer a research question about state politics in Ohio. And I know that Ohio has 88 counties, but I'm not going to be able to go to each of those 88 counties and survey people in every county. So I'm going to list out the 88 counties, and then I'm going to randomly select, say, 10 of those counties. And then in those randomly selected clusters, in this case a cluster is a county, I'm going to go to that county and then take a simple random sample of people from that county. This is a way to cut down on time and effort and expense that would be required for me to sample people in each of the 88 counties, but still have a random sampling strategy. So I didn't pick counties that were most convenient for me to get to. I didn't pick counties that were most central or most populous or anything like that. I listed out all of the county options, randomly selected from them, and then went to those counties to randomly take samples. Another research design where this might be useful is, let's say that I was interested in a population of college students at public universities. There are lots of public universities in the United States, so I'm not going to be able to go to every public university and take a random sample of students. But I could list out all of the public universities in the United States, take a random sample of those universities, so those are my clusters, and then go to each of those sampled universities and take a random sample of the populations of students within those universities. Which random sampling strategy you use depends on what the research question that you're asking is and whether you have particular requirements for the composition of the sample that you're taking, and whether you have particular limitations on where you can go to collect your data for your random sample. So it is more straightforward, usually, to analyze a simple random sample. You're going to use some more advanced techniques to analyze a stratified or a cluster sample, but the stratified and cluster sampling strategies allow you some different benefits that simple random sampling doesn't allow. So the choice of the random sampling strategy really depends on what your particular application is. So that has been our discussion on survey sampling. Thank you for listening, and I will see you next time.